All right, the distributive property. Now let's see if we can paraphrase this a little bit. I'm going to just read this verbatim, and we're going to see how you can change it. Hopefully, you guys, when you received that, you guys wrote your name on it, the class period, and the date. So let's see. What you're going to be able to do, find the greatest common factor of two whole numbers, minimize, of two whole numbers less than or equal to 100 and a least common multiple of whole numbers less than or equal to 12. Blech. Use the distributive property to express a sum of two whole numbers between 1 and 100 with the common factor as a multiple of a sum of the two whole numbers in common. For example, wow, 36 plus 8 as 4 plus 9 and 2. Okay, and this is how you're going to change that. Let's see. How about use the distributive property? So you're writing this, and I'll be able to. Use distributive property to add two whole numbers. So use distributive property to add two whole numbers. To add two whole numbers between 1 and 100. Between 1 and 100. Two whole numbers between 1 and 100 and not mine. So probably to add two whole numbers between 1 and 100. It was somebody's cell phone that they forgot to put in their locker. You know, we're just going to leave it at that for right now, because it gets just too darn wordy. It just gets too wordy. And whichever one of you three that was, make sure you turn off your cell phone and put it in your locker. Good. It's supposed to be off and in your locked locker if you have one. Off and in your locked locker if you have one. So, well, yeah, school started, so that's where it's supposed to be. Christina is making bead necklaces. She uses 3 blue, 2 green, and 4 black beads. Did I say purple? And then repeats the pattern. If Christina uses 15 blue beads, how many beads does she use all together? Okay. Kristina's making bead necklaces. She uses 3 blue, 2 green, and 4 purple beads. So what's happening to this number here? Okay? Yeah. It's getting bigger, exactly. So she uses 3 blue. So this is what things we're looking at. This is how we're pulling out of this. 3 blue, 2 green, and 4 purple beads. But rather than going from 2, there are 3 blue, she's going to 15 blue. So what's happening to the blue? It's increasing by a multiple of 5. It's increasing by a multiple of 5. So what's going to happen to this? So it's increased by a multiple of 5, right? Okay. And we used to have 3 blue, 2 green, and 4 purple, right? Don't want to do that green. And our fake purple. Yeah, it is orange, but I don't have purple in this program. Okay? So see how this is happening? We are increasing it by 5, and there's going to be numbers on the inside of it. There's going to be numbers on the inside of it because it's increasing by 5. And the reason why we put it like this is because the green and the purple also have to increase by a multiple of 5. And this is how you would set up a distributive property. Okay. Any questions on that? Just setting it up just as an intro. All right, let's get down to business, learn how to do it. So we have the distributive property. So we're writing this down. The distributive property lets you multiply a sum by multiplying each addend separately and then add the products. An addend is a thing inside of a problem where it's being added together before the solution. The distributive property lets you multiply a sum by multiplying each addend separately and then add the products. And then add the products. Ooh. And add the products. So Ab, you want to put your phone in your locker, turn it on, turn off the phone on the way. What? Well, you're gonna go put your phone in your locker, not forget to leave it in there. So turn it off as you're going down. The distributive property lets you multiply a sum by multiplying each addend separately and then add the products. Here's the situation with the addend. This here is an addend. Okay? That is an addend. So we have the distributive property. Now the distributive property, I'll show you the distribution. We have 6 is being distributed to the 9, 6 is being distributed to the 14. So it comes out to be 6 multiplied by 9 and 6 times 14. Okay? 6 by 9 and 6 by 14. See how that 6 is going in there? It's being distributed to each one inside the parenthesis. The same way that when I hand stuff out, I have everything here, but I'm distributing it to each row. Yes? Does that make complete 100% sense? Not like the I'm sleepy on a Monday. Wake up. Yeah. Wake up. Yeah. And if anybody's actually watching this video on YouTube, I'm really sorry if you're wearing headphones. All right. Yeah. You're sitting in your room by yourself doing your homework. All of a sudden, your parents hear you scream. Yep. So here's the situation. Is that an example on there? Let's see. 6 by 54. No. Okay. So this is also, the distributive property is also useful with mental math. Whenever I multiply big numbers together, I'm using the distributive property in my head. For example, if you wanted to quickly multiply 4 times 53, 4 times 53, you can easily do 4 times 50, right? Because how it works is you have to, you just do 4 times 5 and you add a 0, right? Because that's something that you guys should know how to do. 4 times 5, you add a 0, so it's 200. then you know that there are 3 more sets of 4, correct? Because when you multiply, all you're doing is you are doing... that's not it. Oh, yeah, it was. There. You are multiplying 53 4 times, or you are multiplying 4 53 times. If you multiply 4 times 50, you are taking care of 50 of them. You need to have 3 more sets of 4. So we have the 200, then you add the 12 more, and it's 200 plus 12. So in your head, what you just did was 200 plus 12, or you did the 4 times 50 plus the 3 times 4. And you'd be able to get right at the top of your head 212. You could actually really impress some people with that. It'll really help your multiplication facts when you have 2-digit numbers and 3-digit numbers being multiplied by 1, or 1-digit numbers. So additional example 3, let's see here. Is that one on there? Yes. 6 times 54. Okay, good. So using the distributive property. So we have 6 times 54. 6 times 54, and right now we are back onto your page, so if you zoned out for a bit there, we're back with it. So 6 times 54, let's see how far this is going to go. Okay, I want you to rewrite 54 as being 50 plus 4, please. Rewrite 54 as being 50 plus 4. So you're doing 50 plus 4. So now we have to multiply it by 6. So I want you to write 6 plus the quantity 50 plus 4 like it is on the board up there. If you can see it, yeah, you can. 50 plus 4, those two numbers are being multiplied by 6. Yep. You got it, brother. So now we're going to use the distributive property. Okay, now we're going to use the distributive property. What is 6 times 50? Yes, sir. Yes, sir. 300. Good job. 300. And the way that Denver possibly just did that is he knew that 6 times 5 is 30. So that means that if there's an extra 0 in one of your multipliers, there's just an extra 0 with the product. So we have 6 times 50 we have to distribute. So we just found out that that is 300. Then we have plus 6 times 4, which is 24. So we have 300 plus 24. Yes, sir. 324. Yep. 324. So you can do 6 times 54 in your head muy rápido, very fast. Okay. I want you to make sure you have all those steps on your notes. Make sure you have all those steps in your notes. I'm seeing a couple of you that don't have what we've been doing on the board. It's not how this works. I'm not practicing my handwriting for the fun of it. This is for you to use when you're doing your homework tonight and look back upon. Because this is the time now where you're writing stuff down, and then the time to comprehend it is when you're working on it. Yep. Now there's also, yes, ma'am.
Why did you get 324?
Did I write 54 earlier? No, I have 24.
The problem is
times 54. 6 times 54. And we rewrote 54 as being 50 plus 4. Then we distributed the 6. 6 times 50 went here. 6 times 4 went here. Yeah. Abby?
Wouldn't you also be able to do this like instead of having to do all of the work and stuff?
6 times 5 and then 6 times 4. You're leaving out a 10 digit though. You could do that. I mean, if you wanted to, if you want to do 6 times 5 plus 4 plus, yeah, no, that wouldn't work. Yeah, that wouldn't work. Now, this is another method that you could do this. Subtraction is often a little bit more tricky with this as far as mentally. So, you could do another way. You don't have to write this one down. 6 times 60 minus 6. All that we're trying to show you is you can have whatever you want inside of this parenthesis using the distributive property as long as it equals 54. Do you agree that 60 minus 6 is 54? Yeah, it is. It's the same sort of deal. How come we have so much less written than we had? Okay. Didn't you hear me when I was walking right past you saying you need to have written down what I have written? Okay, let's get with it now, please. Okay? So we did it that way. We distributed once again. We broke 54 down into being 60 minus 6. Then we distributed the 6 to the 60. That's right here. We distributed the 6 to the 6 right there. We kept that sign as being subtraction. It has to stay the same. Has to stay the same or else it won't work with the distributive property. No. Then we have 360 minus 36, and Sheboygan, we have the same number, 324. All right. 8 by 19, that's what that says in that hole punch through there, okay? 8 by 19. What are some options that we could do here that will have the sum or difference of 19? Yes, Toby. Yes, Toby? Yes. Sorry, that was my fault. Because I wasn't confident about your name. Yes, sir. 10 plus 9. Oh, did you say 10 plus 9? You did say 10 plus 9. Okay, I think I said I lost. Okay, 10 plus 9. Beautiful. 10 plus 9 would work. Good. Anybody else? Yeah. 8 times 10? Yes. Okay, yeah, that's the next step. Good. I'm trying to find something else that has a sum or a difference of 19. Yeah. 20 minus 1. 18 plus 1. We're trying to find ways to break this down, that 19, the same way that we found this guy, 54, and we did 50 plus 4. Now do you see what I'm looking for? So we have 8 by 19. We just had 10 plus 9. 28 minus 9 could work. No, not during the passing period. No. Okay? All right, we're going to continue on with this. So we had 10 minus 9. Well, I'm going to do it a couple ways just to show you that you can do multiple ways. You can see how it works. Come on. What are you doing? Stop it. So here's the way that the person who made this PowerPoint did it. They did 10 plus 9. I'm going to do it a different way. I'm going to show you. I'm going to do it as 15 plus 4. So I want you to write one of these ways. It doesn't matter which one you want to do. Okay? Lucas, you writing this? So 8, 10 plus 9 on that side. Then we are going to distribute our 8 into the parentheses. So we have 8. I'm going to multiply that. I'm going to multiply that. I have my 8. I'm going to distribute inside here. I'm going to distribute inside here. So now I have 80 plus 72. Here I have not as easy of one, but I'm going to use the distributive property in my head to think about what 8 times 15 is going to be. It's going to be 80 plus 8 times 5, right? 80 plus 8 times 5, which is going to be 120. Oops, I'm jumping ahead of myself here. 8 times 15 plus 8 times 4. That one was 120 plus, is that 8 times 4? Yeah. It's 32. Yes, ma'am. 152. Yep, we will be getting there. Let's see if they've got this one here. Then we have this guy, 152. Beautiful. And on this one, we have 152 as well. Yeah. Did anybody do a different sum of those two? It's whatever you like. Which one do you like better? You like the one on the left or the right? Left. Here's the difference as to why this one over here is nicer than this one over here. Okay? Look at how big of a number I have in my sum. See that 15? You're able to do that as being 6th graders. But that 15 isn't as nice as a 10, right? Okay, and you know how to do 8 times 9 much easier than you would know how to do 8 times 15. So this is exactly what we just did. So we used the distributive property, then we multiplied, then we added. Good. 152. And then there's a method 2 of doing a difference, a subtraction. No, thank you. But it's just showing you that it will get the same thing. The GCF and distributive property. Yeah, okay, this is your next one on the backside top. So we're going to rewrite 18 and 24 using the distributive property and the GCF. This is from last week, last Wednesday. First, find the GCF. Use the 2 remaining factors to put them in the parentheses. So, what is the greatest common factor of 18 and 24? What is it? 6. It is 6. Okay, it is 6, and the way that she just did that was possibly a couple ways. And what's your first name again? Mackenzie? Do you go by Kenzie? Because I saw it on your water bottle. Yeah. You go by Kenzie? Well, doesn't really matter. Okay, well, what would you like your teacher to call you? Okay, what I don't care had just then, what? See what I did there? Yeah, right? I should monetize my YouTube with just my awesome jokes. Where was I? She knows her multiplication table. She knows that 6 goes into 18 and 24. And also she's like, okay, does 18 go into 24? No, not really, not necessarily. And also she could have been doing the divisibility rules. By the divisibility rule, 6, it goes into 3 and 2, so she knows that both of those are. Boom, okay, there's a summary of last week. So she puts it 6. Whoa, okay. I don't know. There it is. Okay, so there would be the list method of listing out the greatest common factor. I have no idea what's going on with that slide. But I do want you to list out the factors. So you're going to write down what it says up there. 1, 2, 3, 6, 9, and 18. Those are the factors of 24. So now these are of 18. And this one's going to be of 24. There. That's the list method of 24. So this is summing up what we did last week. And just as a friendly reminder, usually isn't this cold in here, but I wear a tie and pants every day, so as long as I'm comfortable, that's because I'm the most important person to me. All right? And while it's still warm out, keep in mind that in the school it's pretty cold. Mm-hmm. Yeah. So because of 6 being the GCF, we're going to pull 6 out of 18 and 24. Now, this is going to be very similar to the ladder method at this point, because what we're doing is we pulled a 6 out. I'll go with it. Then that would leave 2 numbers on the inside. What would be left on the inside when we pulled a 6 out of those 2 numbers? We pulled a 6 out of those 2 numbers. Well, here's something that looks familiar. Where is it? There we go. What if we did this? What if we did that? Okay, yeah. 12 and 18? Not 12, Ms. Bear? What you think? Think of the ladder method. What would we put underneath there? This isn't the way that we've been doing it because we put out 6. Denver? Yeah. 3 and 4. 3 and 4. It's similar to that. So we would have 3 here and 4 there. 3 and 4. 6 is a GCF, and you pull that guy out. So I want you to mark on there that 6 is the GCF. And that's why you pulled that one out of the 2 numbers. Yes, ma'am? What I mean? We'll do the rest. What's right? What 2 right? Right exactly as that shows up there. Yep, exactly as it shows up there. And then as we do more examples, it'll be clearer. Yeah. You're almost there. I want to see a little bit more. See how you've got the 6. Yeah, right. What's on the bottom there? See us? You got it? Cool. Good. Let's do another example. So then we could also use the ladder method if we wanted to. That's how we would find that it was 6. When 3 times 2 equals 6. And that's how you needed to pull out the 6. And those are the factors, 3 plus 4. So that was what we've done already. Yep, it's the same exact answer, just a different way. Rewrite the following using the distributive property. Now, is that the first example, 1525? All right, we're going to do this one together. The next one I'm going to have you guys do on your own. So I'm going to erase that. It could be in any GCF form. I like the ladder method, so we're going to do the ladder method. So everybody do as I do. 15 plus 25, we're going to think about... I didn't mean to put a plus sign there. 15 and 25. I'm going to use the ladder method, and we always take out a 2, 3, or a 5, right? Does 2 go into that? No, because it doesn't end in an even number. Does 3 go into that? No, you can't pull a 3 out of them, so we're going to go with 5. So this becomes 3, that becomes 5. I have 2 prime numbers there. Can I keep going? No. So that means that I have to pull out my GCF, which is 5, out of this. So I take a 5, and what are the factors left over? 3 and 5. For those of you that are wondering, this guy reversed out. There's where those 2 multiply together. This guy is from having 5 times 5. So we're doing the distributive property backwards. Yes, sir. Yes, sir. Actually, can you hold it for 4 minutes? Because some class is over. Okay. So that's how we did the rewrote using the distributive property, and we're done with that. I want you to do 48 by 72. 48 by 72. First thing you have to do is find the GCF. I want to see either the list method or the ladder method on there, please. List method or ladder method, so you can find your GCF. Greatest common factor. Right? Oh. What you got? You want to write it up here? Here you go. Yep. Okay, 9, 1, and 2. I pulled out 24. The GCF of those two is actually 24. So you would have 2 plus 3. Yes, ma'am. What'd you get? 4 and 6? Yes, because this would be halved and that would be doubled, but you didn't have the right GCF. You didn't get the GCF, so it's not. Well, yeah, you would need to have the correct GCF. 9, 2, and 3. Oh, I know what you did wrong, Kenzie. It was 9 and 48 is not correct. So here's your homework due tomorrow. That one we can skip it. Yeah. 16. 16 is also a factor. There's a couple that No, we're not going to finish it tomorrow. There's your homework. So pull out the GCF and go from there. See you guys tomorrow. Yes, you do. Uh-huh.